Hello. Wow, it's so weird to hear my voice everywhere. My name is Bojana, as Kate said, and this is Birdie Man, or Beardy Man, for those of us native English speakers. And he's the mascot of Typeform, and that's where I am the lead UX designer. So I'm really happy to be here today, and I'm really happy to speak with you, and I know I'm the only thing between you and lunch, but I promise to make it as interesting as possible. So let's get started. So today I want to talk about designs for the human brain. And the human brain, in particular, is what we design for, right? We design for humans, and therefore we design for the brain. And when I was thinking about what is the best use of these 20 minutes that I have with you, I thought about what might be the most useful is to think about and talk about some of the core limitations and, at the same time, benefits or exploits of the human brain. You can think about it like design hacking, right? So when we understand the why, we understand why something works the way that it does, we are in a better position to create applications or whatever it is that we're building or designing to be understandable for that context, right? And so I'm going to back up just a little bit and talk about the first topic, which is really like, what is design? And there's so much kind of disagreements, and everybody thinks a different thing, but I'm going to go with the definition. So the design is a plan or drawing, right? You can think about that's created to build something. You can think about architectural plans. You can think about business processes, circuit diagrams, sewing patterns, as well as comps that you work on a daily basis with, right? But there's so much more to it, right? Like, designing includes considering the aesthetic, the functional, the economic, socio-political, as well as design context, right? These are all really important when we're designing products or building products. And it may involve considerable research. It may involve interaction and adjustment, and then redesign or iteration, as we like to call it, right? So, and then user experience design is this other level that's really focused on making things more usable and making it friendly for the customer and making them feel good when they're using something, right? You're working on the experience. And so, so when we look at things, we've been making things for other humans for a really long time, right? Like, we've been designing things for a long time. Architecture, simple, or not so simple, right, clothing. And now this is the new evolution of design, right? But we live in a world of interfaces. We live in a world that, at least I like to think about it that way, and it makes the most sense to me. And if you look at something like the hand, right, you have this really, really dense tissue, like tendons and bones and structures that are all obscured by the skin. And to us, it seems so easy, right? But then we're able to do some really complex things. So what we have, the skin, is the interface of everything that sits behind it. And if you look at buildings that we live in, and walls are full of wiring and systems, essentially, that make the building run in a certain way. The switches that we see on the walls are interfaces, right? And here's some examples. So UIs are really the next iteration of this kind of abstraction of complexity in order to make communication and use easier and make our lives easier, right? It saves us time. And so I like to think about the number one purpose of UI being really the abstraction of complexity. And if you think about it in that context, I think it starts to feel like you can do a lot more than just make it pretty, right, on the surface. It's really how the system itself is put together. So seeing that we're really interested in designing for humans today, and we're talking about how to design apps, right, that people use on their phones, I'd like to talk about the human brain a little bit too. So there's been a ton of research recently, and really particularly because of new research and or really advances in technology that have happened in order for us to be able to understand a little bit more, or a lot more, really. But we're still just scratching the surface. There's so much more to know. And I'm going to generalize a bit, so if there's any neuroscientists in the audience, please excuse the oversimplifications and understand that it's done in the interest of better design. And for the purpose of today, I like to think about the brain as having 3 parts, right? And it's kind of evolved on top of each other, kind of like layers of an onion, right? Like you have the base layer, you have another layer above it, and then the one on top. So the brainstem is the part of the brain that really regulates our core function, like breathing, digestion, safety, as well as procreation. And it's been around 300 million years, so that's a really long time. These are the types of animals that have this type of a system. The next level up, we have the middle brain. And so this is where our emotions are seated: fear, anxiety, joy, happiness. And the top part of the brain is the newest part of the brain, and it has evolved around 200 million years ago. Let me check, because I want to make sure I get that right. So yeah, 200 million years ago, this part of the brain started to develop. And it includes the prefrontal cortex as well as the neocortex at its top layer. But imagine it's really a structured on top of the other. So you have 1, 2, and 3. And so in the last 2 to 4 million years, this part of the brain has actually grown 3 times, right? So it's gotten bigger. And in the last 30,000 years, it started to shrink again, and we're not quite sure why. Everybody's still debating about it, but the point that I'm trying to impart is that the difference and the changes that are happening in the brain are counted in thousands of years and millions of years. So what that means, this is where we control, right, logic, conversation, written language, communication with other people. And these are the types of animals that have a prefrontal cortex, have the most expressive. So most mammals have it, but for us, it's the most developed, right, including elephants, dolphins, and monkeys. And so we benefit enormously as builders and designers of software to understand how the brain works. And to remember that the older parts are still there. This new part of the brain, the prefrontal cortex, is the part that understands language and written communication. And so the older parts of the brain are still there, but they don't understand written communication. So if you've ever been in a position where if you've gone skydiving, you know how this feels. You're sitting there on the edge, and you're saying you're going to go, right? But there's that part of you that just doesn't want to go. And it's that kind of tension between those two, because the older parts of the brain aren't really understanding that you're safe. You still have the fear. You still have the anxiety, and it's never going to go away. So when we design, it's really important to understand these parts and how we're communicating with each parts of the brain. So how is the human mind static? So there's essentially characteristics of the brain that are going to be static. They're never going to change, or they're not going to change anytime soon enough for it to matter. And one of the parts that I want to talk about first is the vision. So what we see, how we see now, is always how we're going to see. And this is really important for us when we're building applications, because of the nature, the way that we are designing them for vision will help us communicate them better, right? So vision is optimized for contrast, and it's not optimized for color. And you can see here, these orange dots are the same exact color. But because the backgrounds are different, they look totally different, like a different shade. So what we see really well is contrast, not color. So anytime. Oh yeah, fun fact, right? So by the time that everybody in this room is 60, your eye will require 3 times more light to enter through the cornea in order to see the same thing that you saw at 20 years old. So as we start to design, and we have plenty of users that are older, right? We have plenty of customers that are using apps way older, but we tend to design as if they can see as well as 20-year-olds. So our peripheral vision is also really bad. We can see really straight ahead really well, but when it comes to sides and periphery, we don't see well at all. And wonder if you've ever wondered why flashing banners, edges, like icons flashing on the edge of your vision are so annoying. It's because the peripheral vision, although it's really bad, is really good at detecting motion, because that was the most important thing to detect. And so when you have distractions in the side, you will get 2 things. People either habituate to it, and they're gonna they're going to totally ignore it, so even if you display something important in the periphery, they're not going to notice it, or they're just going to abandon it, because there's a certain percentage of the population that can't at all habituate to that. So for them, it'll continue to be annoying. So designing for how we see. So I think it's really important to optimize for text and background for context, right? That affects readability. Anytime you get away from the ultimate contrast, it's going to impact your readability. I don't care if it's super, super dark gray, like very, 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 very dark gray, like in the Lego movie for Batman, or if you've seen it. Multiple muted colors are also really difficult to see, especially in the periphery. So anything thin text that's in color, small objects like icons that are colored and don't have that like 100 or the most amount of contrast possible are going to be affected by this. So when you use peripheral motion, if you need to display something in the periphery, make sure that you do it sparingly and only when you need to. It's kind of like using the color red, right? Like that's the red, no, don't go, stop. It's the same thing. So memory. When you look at memory, it's super unreliable, actually. When we remember something, the reason it's unreliable is because when we remember something, the brain pulls it out, puts it together like a puzzle piece, because memories lived in all different parts of the brain, puts it together as a puzzle, and then breaks it back down and saves it again. So every time you recall, it's being rewritten, and it's being affected by the context in which that you're recalling it. So if you feel really good, or if you feel really bad, it'll get, or whatever it is that you're thinking about will affect the memory. So recall. Recall is really hard. If you think about how long it took to memorize the multiplication tables when you were a kid, things like that. If you've ever you've met a person, right, and you remember their face, and you remember who they are, you remember the context, but you can't remember their name. And then they say their name. But in your mind, you go, oh my God, I knew that. How did I not know that? It's because recall is hard. You're made to recognize things. So recognition is a lot easier. That's why we like to take photos. That's why we like to make scrapbooks. We like to collect mementos, because it makes it easier for us to recall. So how does this affect design, right? If we are creating an app that is allowing users maybe to read something, bring them back to the same place that they left off, right? Like these are really small things, but they make such a big difference. Visually distinguish done and not done. I mean, the search engines do this all the time, but we tend to forget about it, right? These are like really old, tried and true techniques that work. The brain is also goal-focused. So when we have a certain goal in mind, we tend to ignore everything else in the periphery, or that's not relevant to the goal, right? If you look at this, one of the things that really describes this is change blindness. So if you're looking at these two pictures, can you tell me what the difference is between the two? There is one. And it's not easy, right? It takes a long time. It's because we're actually bad at this. We don't do this well. But when a person is focused on a goal, they'll just think about that specific end goal, right? So make it easy for them to understand their task, and anything irrelevant to the goal will be obsolete. If you have ever been in an app that asked you for something before it was necessary, this is exactly that kind of concept. In apps that have asked for users to create a login or create an account, require them to create an account before checking out or finishing the process, the payment process. It's the same exact thing. And now, really, it's the opposite, right? Like, how is the mind plastic? How is the mind changeable? So the brain is a pattern recognition machine, and I'm guessing that most of you saw something in these pictures. It's the face, right? You can't help but notice it. And we're particularly wired to recognize faces. And so one of the things about designing with patterns, which patterns are visible and which aren't, or which patterns are recognizable and which ones aren't, right? Like switches, like toggle switches, that's something that exists in the physical world. and it's something that we use all the time, light switches. But something like the hamburger menu, and there's all kinds of like huge discussion about this, is not as recognizable. But over time, it becomes recognizable. Over time, people can habituate to understanding what the hamburger menu is. So it's really important to understand these two differences and use it accordingly. Some of the things that you can do is you can use recognizable patterns as metaphors, and metaphors for easy recognition, right? Like take a pattern that exists in the physical world, in the real world somewhere, and apply it again, right? You could evolve a button or an icon over time. If you have a large user base or a lot of people are using your app, you can change things slowly, and then they will actually habituate to it. And you can also create some depth in the visual language. I know flat and kind of, I don't know, in the design world, this is, everybody loves a new thing, right? So it's flat design is the new thing. But the problem with flat design is that we are tactile beings, right? We've evolved to experience the world in a 3D way, and it matters to us. And so we can see and read a screen better when it has some depth. I'm not saying we need to go back to skeuomorphic like six years ago or something like that, but it needs to be, a button needs to look like it should be pressed. Or actually, it doesn't need to, but if you want people to understand it better, it should. So memory. Back to memory a little bit again. So mirror neurons. There's been a lot of interesting debate about these, and this is kind of new, and there isn't still a whole lot of agreement about this, but essentially, when we see somebody do something, our brain fires with the same patterns as that person that's actually doing something. And that's how we learn. So mimicry or seeing somebody do something, seeing an example is probably the best way. And so how can we design for learning is that we can show rather than tell, right? And show with examples. Start with the context. If you are entering, if a customer or user is entering an app that you've designed, what do they need to know about the overall structure first? So that when they see it, it'll actually make more sense. If you start with the particulars, there's no context in place for people to remember things. It doesn't mean anything to them, right? And give the relevant info at the relevant time. So how do we learn best? The ease of learning through experience really is the best way that we can learn, and through repetition. But the bottom line, ultimately, is that humans interpret the world in a certain way, right? And certain things about the way we interpret the world are not going to change. It's going to be thousands of years before our vision improves. It's going to be thousands of years before certain parts of the brain evolve, or maybe we're less responsive to peripheral movement, things like that. But we are going to evolve our ability to recognize patterns. And I think that my hope for this talk, more than anything, is to impart some curiosity for you to start thinking about humans as a system, to start thinking about the hardware that we have as something that we have to design for. And it's really not about that top layer. It's not about the visual aesthetic entirely, right? There's so much more to design. And if you have curiosity about these things, and if you learn more about the human brain, about the way it functions, you can do a lot. Because at the end of the day, everybody that touches a product is designing it. Even if you don't have the title of the designer, it's really what you're doing and decisions that you're making that will impact how people perceive what you've built. So we can design for those strengths and weaknesses if we know what they are. But if we don't know what they are, we can't design for them. Thank you.